Hey everybody, it's Mr. Spudik again. Today, I need to give you a harsh reality. Are you ready? Be ready. We do not live in an ideal world. I know. I'm sure you're shocked. And what I mean by that is, we do not get the same output of energy that we put in. So, anything we've done so far in conservation of energy was assuming this 100% efficiency, okay? And for most of the things that we cover, especially say for a unit test, you can assume that. But there are times when we need to talk about efficiencies, where energy will be lost due to friction, heat, or whatever. Now, I don't want you to get confused, okay? The conservation of energy is true still. However, energy can get transferred to heat. So if you have, say, a motor, that energy will be transferred off, some of that energy at least, will be transferred off and lost to the system and transferred off to heat. Okay, for instance, your car, a normal combustion, internal combustion engine has roughly the range of efficiency of only about 20 to 35%. What does that mean? That means the car's energy that you put in, that gasoline, okay, and the explosions you get from the gasoline and that heat, only 20 to 30% of that heat actually transfers to the kinetic energy of your car. That's not a lot. Okay, so what we're going to talk about is just how to calculate efficiency when we have problems like that. Okay, so the whole idea will be us understanding the difference between output of energy and input of energy. And remember that we will always have less output than we do input. The actual equation will be like this. We give it a little curly E for efficiency, okay? And the output will be on top, so any output energy, output work will be on top, any input energy will be on bottom. When you're doing these problems, some students will have trouble knowing and picking which is output, which is input. One thing to always remember is this. We should never get more output than we do input. So if you're about to put a larger number on the top of the ratio than on bottom, you know there's something wrong, okay? Our efficiency value should be numbers between 0 and 1 when you do this calculation, or percentage. So it should be between 0 and 100% only. Now, do you think there's any units given the efficiency? Well, think about the units for the formula. If you have units on top for work, which are joules, and units on bottom, which are also joules, those two units will cancel out. So remember that there will be no units for efficiency. It'll just be a percentage. Thanks so much for watching, and I'll see you next time.